Greetings to all viewers. This is Professor Ankit Singh. We'll now move to the next topic, that is joints in rigid pavements. So why we'll study what are the different types of joints and why do we need joints. Okay. So it is important that the load applied on the slab is shared by adjacent slab also for better performance of pavement. Okay. So we need joints and we need double bars or tie bars in between the any two slabs so that the load is transferred or shared by the adjacent slab. If load transfer across the slab is poor, then distress such as faulting, pumping and corner break might occur. Okay. So if the load transfer is poor, this type of distress might occur. So what are these distress? We'll study in detail in the next module, in module 6, where we'll study the defects and maintenance of highways. Load transfer occurs through different mechanisms. The ability of the pavement to transfer load at a joint is called load transfer efficiency. Okay. Granular interlocking is expected along the cracks that form at transverse joints. For low volume road, the load transfer is expected to be provided by interlocking. Okay, so here we may or may not provide the double or tie bars in between the adjacent slabs. For higher traffic volume, thicker higher double bars are provided. Okay, for higher volume traffic, if it exists on the rigid pavement, then we need to provide double bars. So here you can see the load transfer at joints. So this is a joint without any double bar, and in this case you can see there is a deflection here and the load does not pass on over here to the other slab. So zero load transfer efficiency in this case. But here when you provide a double bar, then 100% load transfer efficiency. Okay. Then purpose of joints in cement roads, in concrete roads. What are the purpose? Why do we provide joints? To absorb expansion and contraction due to variation in temperature. Okay. So why do we need this spacing between the slabs? Because at high temperatures there are chances that the concrete will expand. Okay, if there is no spacing, then there will be bulging or cracking at this portion. Okay, hence we need to provide spacing to avoid warping of slab edges. Okay, we have already studied what warping is. Due to daily variations, there might be a warping up or warping down conditions. Okay, due to the warping, the edges might go up or down. Okay, in order to avoid that, we provide a double bars or we provide joints to grant facility in construction. Okay, these are construction joints. To continue after a day's construction work, we need to provide construction joints. Now, what are the different types of joints? They can be broadly classified into transverse joints and longitudinal joints. Now again, in transverse joints we have expansion joint, contraction joint, warping joint and construction joint. Now here in this figure, okay, this is the road in the longitudinal direction. So along this direction you have the longitudinal joint, and across this you have the transverse joint. Okay, along the longitudinal joint the bars or reinforcement that are used are the double bars, and along the transverse joints these bars. Sorry, this is wrong. Okay, so along the longitudinal, yes, along the longitudinal joints we have the tie bars. Okay, so these are the tie bars, and these along the transverse joint or in the longitudinal direction we have the double bars. Okay, so this here is an expansion joint. So why are we providing this spacing? Whenever either of these slab would expand due to increase in temperature, there should be a spacing here in order to avoid any bulging or cracking. Okay, then this here is a cross section. You can see a double bar is placed over here, and when you use a double bar for an expansion joint, it is fixed at one end and it is free at the other end. Okay, so that it can expand. The double bar can move inside. Okay, and also what you do is you provide a filler in this gap. Okay, so expansion joints, these joints are provided to allow for expansion of slabs due to rise in slab temperature above the construction temperature. It also permits the contraction of slabs. It is provided in India in the interval of 50 to 60 centimeters for smooth interface in winter and 90 to 120 centimeters for smooth interface in summer. The maximum spacing is 140 meters. Expansion joint doubles are specially fabricated with a cap on one end of each double that creates a void in the slab to accommodate the double as the adjacent slab closes the expansion joint. Okay, so as I told you over here, there is it at one edge it is fixed, and at the other edge we have a gap over here and we have a metal cap. Okay, so that to allow for expansion. Then we have contraction joints. These are provided to permit the contraction of slabs. These joints are spaced closer than the expansion joints. Okay, so what are contraction joints? They are joints which are not cut to the depth, okay, but they are cut only to the half depth or even less. Okay, so a cut in the road or in the concrete slab up to half depth of the total depth, so that to account for contraction. Okay, now suppose that this here is a contraction joint. When the contraction of this concrete slab occurs due to low temperature, then the crack will be developed along this point only, okay, and not randomly. Okay, so if you put a groove over here, if you cut out a groove over here, then whenever there is a contraction, the crack will occur at this point only. So using the contraction joints, what you can do is you can control the cracking. That is why you use contraction joints. Then we have warping joints. These are provided to relieve stresses induced due to warping, known as hinged joints. These joints are rarely provided, okay, since we already provide the contraction and expansion joints. Okay, if there is lesser provision in expansion and contraction joints, then we can also plan to provide the warping joints. Okay, then we have construction joints. A construction joint is defined as a joint between slabs that results when concrete is placed at different times. Okay, so you might finish some concrete work by today evening and you need to restart the work tomorrow morning. Okay, so now the setting time and the quality of concrete might change, hence what you do is you provide a joint at the end of the day's work. This is nothing but the construction joint. A header and double basket for a transverse construction joint are shown. Okay, after paving up to the header will be removed. The next paving day will start with new concrete butted up against the old concrete. Okay. Then we have longitudinal joints. All these four types were the transverse joints. Now we have longitudinal joint. A longitudinal joint is defined as a joint between two slabs which allows slab warping without appreciable separation of cracking of slabs. Okay, so the longitudinal joint should allow for warping. Longitudinal joints are used to relieve warping stresses and are generally needed when slab widths exceed 4.5 meters. Okay, if the slab width is less than 4.5 meters, then we may not provide a longitudinal joint. Okay, to aid load transfer, tie bars are often used across the longitudinal joints. Tie bars are thinner than doubles and use deformed reinforcing bars rather than smooth double bars. Okay, so in the case of double bars, the reinforcement that we use is smooth mild steel, and here it is deformed reinforcement bars. On soil subgrade of clay, such joints are provided to allow differential shrinkage and swelling due to rapid changes in subgrade moisture under the edges than under the center of the road. Okay, so these types of joints are provided in order to account for the differential shrinkage and swelling. Okay, in these joints, tie bars are provided to hold the adjacent slab. Okay, along the direction of the road, there might be more than one lane or more than one slab. In order to hold them together, we need to provide these longitudinal joints. Now, we'll just have a general idea about the different types of concrete pavements that can be used. Okay, types of concrete pavements could be unreinforced concrete pavement, okay, which does not have any tie bar or double bar or mesh or any other kind of reinforcement. Then we have reinforced concrete pavement, under which we have jointed reinforced concrete pavement, and we have continuously reinforced concrete pavement. Okay, then under unreinforced we have jointed plain cement concrete pavements. Okay, so this is it for the types of stresses and the joints in the rigid pavements. I'll discuss the numericals in my next class. Thank you.